Hey everybody. Today what we're going to go through is we're going to relate some of the stuff we did back in the beginning of the course with the stuff we've been doing recently. So this is an idea that we've been working with for quite some time now, but we're just going to put some words behind it and give it a name. So especially like this relates to row echelon form. So and that's something we've been doing a lot of. So it's just the property of that we've been checking that we have not named yet for some reason. So with that said, we're going to go through a quick definition of both the rank and the null of a matrix. So we're going to start off with our rank of our matrix, which will be defined as such. So the rank, also written as the rank of matrix A, is simply just the number of leading ones in any row echelon form of A. And A can be a matrix of just numbers of coefficients, or it can also be an augmented matrix when we're solving for a system of linear equations where we have our coefficients and our the unknowns we are solving for in the second part of our augmented matrix. So that the rank also applies to this as well. So some row echelon forms will be different than others, as our performation of elementary row operations may differ between person to person, but either way you will still end up with the same number of leading ones in that matrix, so that will give us the same number as our rank. So one idea to keep in mind is that you actually have to put it into row echelon form before you count the rank. So you can have a matrix that may look like it has two leading ones in it, but once we perform our row operations, we can actually expose that there's only one leading variable and one free variable. So what that looks like, let's say we have a matrix 1, 2, 3, 2, 4, 6. This looks like we have two leading ones, but we know that the second row, we notice that the second row is linearly dependent on the first row. So if I do the elementary row operation where I have row 2 goes to row 2 minus twice row 1, this will give us a row echelon form of 1, 2, 3, 0, 0, 0, and obviously this only has one leading one, so that means that the rank, let's call this matrix D. So the rank of matrix D is 1. So simply it's just put it into row echelon form and then count how many leading ones you have. That's the rank. And then the number. Alright, so another thing is that if matrix A is a M cross N matrix, the rank has to be smaller than or equal to the smallest one of either the number of rows or the number of columns. This might seem confusing at first, but once we look at it, if we put a matrix into row echelon form, each row can only have one leading one, right? Because if I have this as my leading one, this is not a leading one because it's like a following one. All right, that the same goes with a column. If this is our leading one, we would be actively trying to slay this number away, and then we would have no other leading ones in that column. So depending on if we have less number of rows or less number of columns, the rank cannot be bigger than that number, because let's say this matrix was a skinny one, and the number of rows, let's say we only had one row in this one, there cannot be more than one leading one because that would not be leading one. So hopefully that makes sense.